Hello everyone. In the previous video we have seen what is operational amplifier and how to draw the voltage transfer characteristic of op-amp. And also we came to know that depending on the VTC curve, the op-amp will work in linear region and saturation region. So depending on that regions, we can say that there exist two modes of op-amp. One is the open loop mode and other one is a closed loop mode. So what is open loop mode and what are the applications? Why we haven't used the open loop mode of op-amp for linear applications? These concepts are all discussed in the previous video. So now we are going to see what is a closed loop mode. So with the introduction of this, let us briefly glance the most important concept, that is the open loop mode of op-amp, that is not suitable for linear applications. So in the open loop mode, the major drawback of operational amplifier to operate in the linear region is it is having a minimum input voltage. Okay, so with the minimum input voltage, it drives the output of an op-amp to achieve the saturation region. So in order to overcome the drawback, we are going to other mode, that is a closed loop mode. Now what do you mean by a closed loop? So if you see, the closed loop is nothing but some connection should be present between the output and the input. Okay, so loop itself defines that when we are starting at one point, the end point should be end at that point itself. Okay, so this is a loop. So closed loop means it is like a cycle or a circle. So if you see the block diagram of a closed loop circuit, then it is, so this is our closed loop circuit configuration. So this is a open loop mode. Okay, so this can be converted to the closed loop when there is a connection from output to the input. So if there is a connection from output to the input, then we can say that this is a closed loop circuit. So if you observe, this is the starting point of ours. So this is a starting point, so it is passing through that signal and again it is ending to that point. So this is a closed loop. So here we are calling this as some gain circuit and here we are calling it as a feedback circuit. So this feedback circuit indicates how much gain should the circuit present and also how much amplification the circuit should have. So depending on the feedback circuit, again this closed loop is classified into two types. One is a positive feedback and second one is a negative feedback. So when we are considering for linear applications like amplifier application, we are going for negative feedback circuit. Why? Because in the negative feedback we have so many advantages. So one of the major advantage is it controls the gain of a circuit. Okay, and also it reduces the distortion at the output signal, and one of the major advantages is it can increase the frequency of operation, means at high frequencies also this circuit can be applicable, and also it increases the bandwidth. So this is the main advantages of negative feedback. And the positive feedback circuits are all used only if you are using oscillation applications. Okay, oscillators, multivibrators, in that case we are using a positive feedback circuit. So depending on the applications, we are designing this feedback circuit. For linear applications we are using a negative feedback circuit, and for non-linear applications we are using a positive feedback circuit. Now for the op-amp circuit, how this feedback circuit will be. So for simple applications like adder, subtractor, multiplication, divider circuits, we are using passive elements, either resistor, inductor or capacitor. Okay, for other higher applications like log amplifiers, anti-log amplifiers, we are using a BJT circuits in this feedback circuit. In general, for smaller applications, how the op-amp circuit will looks like. So here I am considering a linear application. So for the linear application, one of the major application I am considering is an amplifier, which is a linear application. So for the amplifier circuit, we have to use a negative feedback. Now for the op amp, how it is providing a negative feedback we are going to see now. So if you observe this circuit here, for the amplification purpose, I have to use a negative feedback circuit. So we know that for the op amp we are having minimum of two inputs. One is a inverting input and other one is a non-inverting input. So I am using an amplifier application. So that's why I have to use a negative feedback. So simply I am connecting a resistor, nothing but a passive element, from the output to the inverting input. In this way we are having a negative feedback circuit. For example, if you want some oscillator circuit, then we have to simply connect a feedback circuit from output to the non-inverting input of op amp. So in this way we are using the operational amplifier in the closed loop mode depending on the application. So for linear applications, that is an amplifier application, we have to connect a feedback element from the output to the inverting input of op amp. For example, for other application, if you are considering like oscillators, multivibrators, then we have to connect a feedback circuit from the output to the non-inverting input of op amp. So in this way we can achieve or we can design so many applications of operational amplifier. Thank you.